What color do I have for this graph? All right. So 40 degrees was the temperature I gave you, right? So read from 40 degrees up to the graph, and then we go over. So I'm like halfway between 50 and 75. So what would you estimate for halfway between 50 and 75? 60, 62, somewhere in that range. So 62, 60, something in that approximation per 100 grams of water. If you said 60, I would be fine with that. Okay. So for number 2, I gave you a solubility of what? 100. Okay. So since I gave you 100, find the 100 right here. Read over. And what do you think it is? Okay, 60, might be slightly less. It's not quite 60 because I'm a little off there. My line's not very straight. Maybe 59, maybe 58, somewhere, about down in there. Okay, 59, 58, 58, 59 degrees Celsius. All right, and the last one. If the solution, let's just say is, not if. Is the solution saturated, super, or unsaturated if you have 75 grams and 100 grams of water at 50 degrees Celsius? All right, so change colors here. All right, so we have what temperature? We got 50. And what's in my 100 grams? 75. All right, so 75. So 50 and 75. Looks like it's going to put me about right there. So what is it?
Unsaturated.
I agree. Unsaturated. Any questions about using a solubility graph? Feel okay about that?
Yes.
All right. Let's talk nuclear chemistry.
Man, nuclear chemistry.
Huh?
Nothing.
Yeah, I know. More whack stuff. What's that? I don't care about that. Tell you what, if I finish nuclear chemistry today, I won't talk about acids and bases. How's that?
Well, nothing else on that board.
No. I won't do the acid-base part.
Or the practice.
No, we got to do the practice.
I got that.
All right, so yesterday when we did this, okay, what was the symbol for alpha and beta and gamma? Because we're going to use these today.
It's two on the top of the
It's actually the 4 on the top. Okay, I had the 4 and the 2, and beta was the E with the 0 and the -1, and gamma we said we were just going to write as gamma. Okay, so we said that alpha had a mass of what? 4, and its charge was going to be what? +2, because an alpha is basically a proton, and a beta had a mass of what? Nothing, 0, and its charge was what? -1, because a beta is an electron. Now, it's not a normal electron. It's an electron that comes out of the nucleus. What? Yes. Okay, Markel, put your phone down. Take your earbud out. Pay attention to what I'm doing. All right, and gamma is just energy. So if it's just energy, it has no mass and it has no charge. Okay? Everybody with me on that? Are you with me now? Now, we're going to use this to balance equations today. So yesterday, we talked a little bit about alpha decay. And I wrote an equation on the board. So if I have something like, I'm just going to make one up today, and I'm going to use thorium, which we got yesterday as what I start with. So thorium has an atomic number of 90, and I don't know its mass, and I can't see that, so let me get a periodic table.
It's 234.
234? Okay.
Yeah.
Don't say, because I can't see a doggone thing there on that board as far away as it is. Let me grab a table so I've got one for today. You're going to need your periodic tables, by the way.
What?
I said you're going to need your periodic tables. Okay? Now, we're going to figure out what goes on the line like we were talking about yesterday. Now, the first thing that I would say to you is, first of all, how are you going to know if they ask you what kind of decay it is on the exam? How are you going to know it's alpha decay? How are you going to know that's alpha decay? What? That's right. So when you look at this, you see how it says HE right there? That tells you that it's alpha decay. Okay? Because it has the HE with the 4 and the 2 on it. That's what tells you it's alpha decay. Is everybody with me on that? All right. Now from there, the arrow is basically an equal sign. The mass you have on the left has to equal the mass you have on the right. So since the mass on the left is 234, what does the mass on the right have to equal? 234. Well, what mass do I have right here? So 4 plus what will equal 234? 230. All right, so 2 plus what will give me 90? 88. So 88 plus 2 is 90. So which of those two numbers did we say yesterday we'd look up to figure out the element? The atomic number. So when you look on your periodic table, what element is 88? That's why I said get out of periodic table. Radium. All right, so you write RA for radium. Okay? Everybody with me on that? Now, they might not ask you to write the equation. They might ask you how much alpha decay changes atomic number or atomic mass. So, this is based on what alpha decay is. It's based on the definition. All right? Well, alpha decay is a helium nucleus, right? So, how much does the atomic number change by? Well, atomic number started at a 90. What does the atomic number do? Becomes what? 88. So did it go up or did it go down? So it decreased by what? It decreased by 2. Okay, it decreases by 2. Now, what happened to the atomic mass? It what? The atomic mass was what? And it changed to what? It decreased by how much? All right. So, whenever you undergo alpha decay always does what? It decreases. Okay? They both decrease. The atomic number and the atomic mass. They decrease by 2 and by 4. This will be important when we talk about beta in a minute because they're not going to decrease. Now, slide yourself over a tab.
Me?
Over.
Like this is comfortable.
I'm sure it is. The other end of the counter is just as comfortable as that is.
No, because I can't put my elbow on that.
Too bad.
You made me start to know because I can't lick my elbow on that.
You will survive.
I don't understand how that.
I'm fairly certain you will survive. Okay? I don't know how y'all are going to survive the exam when the stools are put in the back and y'all have to sit in a chair.
I mean, can I sit in that one?
You can sit in a desk chair, and I will have assigned seats. They'll have tags on them, and you have to sit there till the exam is over.
Can you please assign me to the one that I sit at?
No.
Dang. Wait, so why would you do an exam?
Huh? I choose the assigned seats. There's a particular order you'll be in, and I will choose it. It's not alphabetical. There's a method to my madness.
Where's your
I will not tell you.
At my level. So you know.
I will not tell you.
Who you like the most?
This one I
It
did.
has nothing to do with who I like the most. All right, now, beta decay. All right, beta decay is the loss of a beta particle. So it's just like alpha decay, and that was the loss of an alpha particle, except now we're going to write the equation with a beta particle. So you're again doing the exact same thing, you're just balancing with a beta particle. So it's just as easy. So, in that green equation, yeah, we're doing great. How are you today?
I'm good, I'm chilling.
That's good. Where are you supposed to be chilling at other than my doorway?
I'm going to class.
That's good. See if you can't mush on there a little faster. You guys what?
The tree.
Oh, yeah, I got it.
No, I got it.
Alright.
You want to be a Christian.
Yeah.
Oh, good.
How y'all doing?
You're doing good. She got you a tree. Come get a tree. This is from Ms. Baldwin's class.
Yeah.
Oh, good. Building the ramp.
It's being Christian.
How y'all doing?
No.
I decided not to use it.
You're not talking to him anymore? I can't understand why.
He's working.
It seems delightful. To work hard?
No.
I would have guessed that, just on my own. What's his name? Joel.
How you doing?
I haven't the foggiest idea who he is. I've never told him.
Do you remember last
You
semester?
teach your brother
I came
Zaya?
here?
Mhm.
You do?
Yeah.
Alright.
So what now?
I said, you did your brother?
Who's his brother?
Zaya.
Zaya.
Dixon?
No, I did not.
Oh.
He was Mr. or Dr.
It's
Phillips.
super cold. It's super cold.
Look, I've been hot since we've been in the auditorium. I think it's fabulous.
It's hot enough. Ours is cold enough.
Okay, good.
I think so too. Now, if we look at the equation, all right, sometimes this one causes issues because of the -1, but otherwise it works the same way. So on the left, what atomic mass do I have? Oh, the left, 14. So I need 14 on this side, right? Well, that's a 0, so 0 plus what gives me 14? 14. Now, the bottom one is where students sometimes mess up because they get ahead of themselves and they screw up the -1. But think about it the way you would in math class and you'll be fine. Instead of saying add a -1, what number subtracts 1 to give 6? There you go. 7 subtract 1 is 6. Instead of saying something plus a -1, just think of it as what subtracts 1 to give you a 6. So 7. So what element has an atomic number of 7? So it's nitrogen. Now, looking at these numbers, what happened to the atomic mass? Okay, the atomic mass did what? The atomic mass stayed the same. What happened to the atomic number? It increased by 1. So, when you think about alpha decay, they decreased. But did they decrease in beta decay? No. Beta decay did not decrease. The numbers actually went up. And this was part of yesterday's explanation. Do you remember what the neutron broke apart into? The neutron broke apart into an electron. And what other particle do we say it made besides the electron? Anybody remember? What? A proton. So since it makes that proton, Elizabeth, that's why the atomic number increases by 1, because it makes that proton. So that's what causes the number to go up by 1, because it makes an extra proton.
Okay, so the arrow is like an equal sign.
Yep.
So why is it in the middle of the equation? Why isn't it just like C plus B equals 7?
Because it gives off the electron. It makes it, it emits it. Okay? It gives it off, it's released. Emits is a really nice fancy science word for gives off a release. Release. All right, everybody caught up? Because I think we're to the practice piece. All right. So if we do this one, all right, what would we do on the top line? What number would we need for atomic mass? 239. All right, what number would we need to go here? All right, and what element would it be?
Plutonium.
What?
Plutonium.
Plutonium, so Pu. All right, what kind of decay would this be? It would be beta. We know it's beta because this right here is a beta particle, so that's beta decay. All right, for the bottom one, what do we do when both numbers are on the same side? That's right, because the total here still has to equal the total on this side. So the total here, these two are totaled to what? So it has to be 238 here. 90 plus 2 is 92. So what element has 92? Uranium. Now, what kind of decay would this be? Alpha.
Why would it be?
Because it has a helium. Helium is always alpha. An electron is always beta. Okay? I think I'm where I want to be to practice. We don't need that. We don't need that. Yep. Yep, I certainly can. We don't need a disintegration series. I took it off the test. All right. On the front side of the lines, we're doing all of them. On the back side, we're doing the odds.
3 C's.
No, she's just being funny.
Is why you like my hair?
Yes. I think we should do lime green.
Like, what type of line? Like dark but not too light?
Like, this. Like this middle line.
I'll do it this weekend.
Okay. Then you should do that.
I need a pencil.
Get a colored pencil.
What?
Oh my God.
Can she use a pencil?
All right. So on the front with the lines,
Yes.
where you're writing A, B, or G, I want to do all 1 through 10. So if you read number 1, it says, it's not deflected by a magnetic field. These always cause issues for people. Okay? You're doing this based on what we did here. Okay? So this one has what kind of charge? Alpha is what? Positive. A beta is what? And a gamma has what kind of charge? Nothing. Okay, so which one is not going to be deflected by? Correct. So you're going to write G on that line. Okay, so a gamma would pass through the positive and negative field, and it would not be moved towards a positive or a negative because it has no positive or negative charge. It would pass directly through. Okay, so you just write G on that line. Okay, so write A, B, or G on those lines.
We can start.
And on the back side, we're just doing the odds.
This is the back side.
That's the back side.
Is number 3 negative?
Number who?
Alpha? Why is it alpha?
All right, when passed through a magnetic field, it goes towards the negative. Who would go towards the negative? Positive or negative? Has to be positive to go towards the negative. So,
That's beta.
Oh, it's what?
yes, you can.
That's an
Let me see if I can find.
Oh, yeah, deflected towards the positive, yeah. It's not on the negative. So if it's towards the positive, it's a helium nucleus. That is alpha, right? It's even here.
We're doing all of these odds there.
Yeah, because energy.
No, get out of my Pringles. That's for lunch.
Yeah. Like a twist. What? What you say?
Barbecue
What? What'd you say? Is there a back?
Yeah, the back you're doing the odds.
It's 12. It can pass through 7 centimeters of lead as gamma, right?
Yes.
No, Is that one of the picture right there? Those vessels are pretty good.
You can't see you.
Uh-huh. Some of us.
Yeah.
From sitting down.
Nah, just say sit down.
I'm kind of a freak on this. So,
Miss Burton.
This one you would be.
Yeah, you got a voicemail.
Yeah, two.
Okay.
And then I.
I'll pass on like your Instagram photo.
What?
Somebody will live.
Somebody will lie.
Somebody will live.
Okay, that's the people join.
I bet.
We will.
So live.
You can't see loud.
You see, so what do you do for
Say
this?
what's up. Sound yourself up, right?
Wait, so the backside you said,
What
or
you
the odd one?
Say what now?
The backside you do the odds, right?
Yes.
I don't know what it is. It's kept wrong.
So what do you do for live? It's like
Boy, with my
-4,
phone.
-2, so it's 80, right?
Oh, nah, now you do. What you say?
Yeah.
Why you got headphones?
Same reason why you got a pen in your hand.
We don't do headphones here. We listen.
Would you do there?
That is -80.
I'm a rookie.
I just take something.
-86.
Shoot, I gotta call.
That would be -2.
Oh, she bought. Oh. I'm taking this off.
Go ahead, somewhere at Walmart. Markel, put it down. 5,
Yeah.
4, 3, 2. Markel, it's going.
I tell you, this your fault. Acts nice. She messed up my head with this wall.
So is this one 230 and 90? Or 230 and 80?
Now be easy.
Yeah.
Who told you that?
Oh, yeah, my dryer, wash it.
What's that? 238 and 92. What's 92? Is it just you? This one is 202
Yes, I heard.
and 80.
You're not funny.
No, I think
Alright.
I do.
You're not funny.
Because he only
That's all right. He knows everybody. You want to do
All right, we done?
No, wait.
that?
I'm on the last one.
Okay.
I need
Y'all,
to.
I think y'all both. Y'all
The gamma has no effect.
Oh, okay, then I know.
You just do it the same way. I was just submitting your time, so to the spreadsheet.
I ain't gonna say that.
This one's 222 and 80.
All right, are we done?
Yeah.
Come on, guys. I want to run this, and then I want to do confusion.
Confusion was whack.
You back over there.
You back over there, dude.
She got my pencil.
And I'll get this in playing time,
Here.
but I do want you over there.
How many times do
I like
I
calling it like this.
How many
You like
times do I have to say it?
What?
We got mine first.
So what?
What you?
Whack.
I know.
I don't like that word. I prefer a different word.
I'm sorry.
She said blank.
She said,
Why are you sitting there pointing your pencil like an idiot?
okay.
You prefer.
Tear fell. I think it's threatening us. I think that's a threat.
Just remember, the lady in Burlington's in jail.
Right. Markel Floyd.
You said Lady Burlington?
No, the lady in Burlington. She was an EC teacher. Apparently, she quit her job. She threatened to shoot up the school. She's in jail.
Say that as a threat though.
I don't know if she took leave of her
Someone said that, like a
sentences.
teacher. I can see
What do you mean?
saying
What?
that.
It did happen.
Are you crazy?
Yeah.
After teaching for 28 years, I fully intend to collect my retirement so I
And
won't
then
count.
shut up the school.
No! I would not look good in an orange jumpsuit or stripe. I look like a Johnny Pumpkin.
But you won't-
It only goes so far. I still look like a pumpkin.
We can make it work.
I like it work. What?
How long you think you'll be in?
And for a while.
Waiting on it.
I mean, somebody may eventually post her bail, but she's an idiot.
But what if she gets posted?
We could go to jail for doing that.
Yes.
You can go to jail, wait, what is
For
that?
like making.
For communicating a threat.
Oh, yes,
Like
you
a
can
violation
go to
of
jail
freedom of speech or something?
No, that's not freedom of speech. That's me going out in the hallway and yelling fire.
Yeah, like that.
You can't do that. That's not freedom of speech.
I mean, like a violation of
You can go to jail for that. 'cause
Yes, you can. That's my point.
That is not a, no.
That is.
Like,
You
you
can
can
say
say
whatever you want. You are threatening to kill.
As Ms.
like,
Wall
a bunch
says,
of
being good
people.
is stupid
Freedom of
doesn't
speech.
count.
a violation of it.
Like, you can say whatever you want. No, you can't. Oh,
I wasn't done.
yes, go for it.
I don't want to finish now. Since you-
Oh my God.
You put it on the spot. So you looking for it?
No.
How many times?
It's beta.
11.
All right, we got it.
I'm done.
Let's see. I found the article. See what they charged with. Blah, 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 blah. With a felony charge of communicating a threat of mass violence. And I don't know if it'll tell me what she could get.
Was she doing like in a joking way?
I don't think so.
She posted it or just said it? out
What
loud?
happened about that one teacher that held the gun to the kid?
I don't know about that one.
Posted that.
I don't know. She told me.
No, he took, a kid brought a gun to school and the teacher took it and gave it back to the kid at the end of the day.
Yeah, that was in Forsyth County, I think.
Oh,
That was close.
can't teachers have guns in Florida?
Oh, yeah.
Not there.
I mean, teachers can have guns here, but we can't. I mean, if you brought a gun to school, I can't hold it, hand it back.
No, like,
Wait.
teachers
Okay,
can
you're
legally
done.
have
I'm
guns
giving
in
it to
class.
you at the end of the day.
No, that's right. We're not
What?
allowed to have
Put
guns.
it in there,
If we have them in our cars and they're secured, I believe we're allowed to have them on campus.
What's this go?
You have to check with Chatterton, but I believe that rule has changed in the last 10 years. At one time, we were not allowed to have them on campus, but I believe you are. But no, we're not allowed to carry them home with us. Some states have changed that. I want to say Texas may have. No, she was charged with felony communicating a threat of mass violence. Because she made threats to shoot up the school.
Just like that.
Yeah.
She probably was like, I quit and I'm gonna shoot it.
Yeah. I mean, the school doesn't even have a name listed on the website anymore.
It seems like that's saying policy.
I mean, you gotta worry about somebody's sanity when they do that kind of stuff. All right, so where's the worksheet? All right, so number one, we already said that one is gamma. So number two, what's the weakest type of radiation?
Hey,
Alpha, very good. Number three, so if you pass through a magnetic field, okay, and you go towards the negative, this is review for the exam. So if you go towards the negative, what charge do you have to be to go towards the negative? You have to be positive to go towards the negative. So which one of them was positively charged? Alpha. They're not all positive. Alpha. All right? It's formed in the neutron if the nucleus breaks apart. It's the beta. Okay? That's formed in the nucleus. All right? When passed through a magnetic field, it goes towards the negative. Which one goes towards the... I read it wrong. It goes towards the positive. It goes towards the positive. All right? Because you're negative, you go towards the positive. So which one was negative? Beta. All right? It's the most penetrating type of radiation. Gamma. All right? Which one is the helium nucleus? Alpha. Which one is the electromagnetic wave? Gamma, because that's the high energy wave. All right? And if you remember, if we look at
hey,
your card, all right, gamma can be found on this part of your reference table because it's a wave, okay? So it's found on that. All right. Number 9, can we stop by paper?
A.
Alpha, very good. Consists of 2 protons and 2 neutrons. Who had 2 neutrons and 2 protons? Uh-huh. It's alpha. The helium has 2 protons and 2 neutrons. Remember, beta is an electron. Can an electron have protons and neutrons?
No.
No, that's why it's alpha. All right, it's an electron.
B.
Beta. Beta is an electron.
She just said it.
I was thinking that, but I wasn't going to say that. All right, and 12. It contains several centimeters of lead. Yeah. All right, so the other, I'm just going to put the answers up, and you check the ones you did. If you didn't do any, I don't guess you got anything to check.
But anybody in here heard banana bus before? I know some. I know you.
Heard what?
Banana bus.
Banana bus?
Yeah.
It's familiar.
What are you doing in here? Get out of my class.
What you need, William?
Oh, the AP,
What about?
you
You need to go see Miss Thornhill. I don't teach AP.
Oh, I take chemistry.
I don't teach you. Oh, I don't have a summer assignment.
Oh,
You just show up and take class.
All right, but.
That's what she wants to say. Because you're whack. You are whack. No, you're whack.
You need to learn a new word for me by Monday, besides whack.
All right, I got you.
Okay. And I don't need a 4-letter word. I don't want to pretend I'm in 4th period.
Can it be 5-letter word?
No,
How many letters?
I don't know. It just does, let me paraphrase. It does not need to be a square word.
Whack is not a swear word.
I know. I was just making a statement that it cannot be a swear word.
Oh, okay.
You know, I'm used to swear words in 4th period.
Oh,
Makes
that's what
many
you mean by
words.
4-letter word.
Yeah.
Oh, okay. It will not be
Ah.
a word. Promise.
And you don't have to write down the others. We're not doing it either. We're just checking the ones you did. Except Urelli, yeah, she didn't do any of them. She ain't got anything to check. You don't have to write them down if you didn't do them. Just say you check the ones you did.
Oh, yeah, I didn't get too bad.
If you didn't do it, you didn't do it. Oh, I don't do that. That email. All right, can I raise it?
The power of rain.
Maybe.
Yeah.
Well, there's the rest of it. For those of you who didn't. All right, and I'm assuming we're doing okay with this for those of us who are trying. Are we okay with how to do them?
Wait.
Yes, no?
Yes.
Yes.
Come on, dude.
Wouldn't it be easier just for myself to learn since it's already
Do
shown?
you mind, Miss Wall? Thank you.
Miss Wall, I found my
I
new
mean, it
word.
would just seem easier to me to buy them already shelled.
Miss Wall.
And have to crack open them stupid shells.
Next one.
Wouldn't
But
it?
that is pretty whack.
He has to get water.
Oh, my.
Yeah, you can have water.
You mind your own business over there.
I like peanuts, but I don't buy them in the shells. I get sick of cracking them open. It's a lot of work. And you can just buy already shelled nuts.
No, you can lick the salt off the shell and
Yeah.
then crack
That's
it.
like those people who eat boiled peanuts. I didn't know what those
Boiled
were the
peanuts
first
are
time I
nasty.
saw somebody eating that. I was like, why are you eating food with hair?
Boiled peanuts looks like
Hair.
animal food.
It does. It's nasty. It's the nastiest looking thing I've ever seen.
Out of all the words.
Huh?
You know what's really
Not like boiled peanuts does.
roasted pumpkin seeds. That's good.
That is.
If we're talking about seeds, pumpkin seeds are the best.
Okay. I've never had those.
Are you serious?
I don't like pumpkin
How old are you?
of any
Don't
kind.
answer that question, but like
I'm 49.
Like pumpkin as well.
Well, then I might try it, but I don't like pumpkin.
that many
So
years.
that's probably why I have not tried it.
You
I'm
like
not a fan of
pumpkin
pumpkin. Of any kind of
pie? You like
pumpkin.
pumpkin spice?
No.
But you're white.
I am white. Glad you noticed that. But I do not like pumpkin. What?
So like, when you
Black.
had pumpkins as a kid, you guys didn't roast seeds.
Look,
We rested the
I throw them away too.
I eat.
After I got past the sliminess of the
I like eating
pumpkin.
pumpkin pie.
Ugh, I don't eat pumpkin pie either. This is the nastiest mess.
No, it's fucking good, dude.
I do not like pumpkin. I don't even like to look at it.
Wow.
Okay, that's why you drank.
I've carved pumpkins a few times in my lifetime, mostly with my own children.
I carved never mind.
I made them in the like the.
Alright, so fission.
Oh,
We're gonna learn about fission and fusion.
we have to do this.
Yeah, we gotta do this. We'll save Half-Life for Monday.
Tuesday.
We don't
Tuesday.
go to school Monday, right?
The next day we're here, people. I'm not yelling Monday either. It's a teacher work day. I'm not coming.
Oh, you're not.
I'm not coming. They said it's a teacher work day, and I said I have annual leave. Sign me up. Okay, that's one of the perks of being a 28-year veteran teacher. I do not have to work those days anymore. All right, so fission and fusion. Now, I like to teach fusion first because you guys can remember fusion better because you remember the word fusion from English class. What does it mean to fuse in English class? That's right. Okay, so fusion means to combine two, Nigel, hush. Smaller, I didn't say finish the conversation. Combine two smaller nuclei into one larger nucleus.
What's a nuclei?
It's plural for more than one nucleus. Okay? So, basically, you would have like a hydrogen plus a hydrogen, and you would get a big nucleus. Okay? So two small ones, and you get a big one.
See, I thought
That's fusion. Nigel, go check.
like normally when how fusion works, like you guys stand and then you're like and then they combine and their hair gets all big and changes colors.
Okay.
Pretty lit.
Okay. All right. Now, yes, ma'am. Yeah. We got 10 minutes. You still have any whole classes left? You don't think so? See, there's no reason to say that. Let me say before you waste one that you might still have.
Yeah.
I mean, if you don't have one, it's not a waste. But if you have one, I hate to see you use it. You got one left that's still worth 5 points. Okay, I was going to say, you might want to keep those 5 points because it goes on your last test grade. And I'm going to add those next week. All right. All right, so the fission is the opposite. So what's the opposite of fusion? No, I didn't write down what it was. Okay, so what's the opposite of putting it together and combining it? Okay, so fission is when a large nucleus splits. Okay. That's why I should learn to spell. I hope that wasn't a phone. You're what?
Oh my god.
Into two smaller nuclei. Okay? So, that's a track. This is why I like to teach fusion first. Because you guys can all tell me fuse means to put together, right?
Yeah.
You just told me that, didn't you?
Yes.
So fusion is taking two small things and making one big thing. So fission is the opposite. So you take one large nuclei and split it apart. So fission is what most of you are the most familiar with. When you hear about power plants, nuclear power plants, when you hear about atomic weapons that we used in 1945, this is nuclear fission. So you start with a neutron. All right, it hits a large nucleus like uranium-235. You do not have to know what the numbers or the elements are. Okay? It breaks apart into a smaller barium and krypton. And it makes another neutron. Now, this neutron hits another uranium. Let me fix that. 235. The uranium splits again into barium and krypton. It makes another neutron. That neutron hits another uranium-235. Now, this process happens over and over again. This is called a chain reaction. Now, there's two kinds of chain reactions you can have. You can have what's called a controlled chain reaction and an uncontrolled chain reaction. Now, if we have a controlled chain reaction, where would we want to use the controlled chain reaction? Where do we use fission reactions a lot? Yes, we do.
Microwave?
No. What?
Power plant.
Yes. Okay. We use these in nuclear power plants.
I said it by the way.
All right, nuclear power plants.
What does that say? Below A.
Neutrons, NEU is what I put there. It's not what I meant to do. There, that makes it a little bigger. Okay. Now, where would we use uncontrolled fission reactions? We would use the uncontrolled in atomic weapons. Now, I'll let you catch up before I finish talking.
So fission is basically the opposite of fusion.
Yes, they're the exact opposites of each other.
You know, when I was in ninth grade,
I was
Curly probably remember. And Dr. Curry said when we asked him about this, he mixed up the words, and then he got mad at us for not remembering. He got like really upset. He was like, "You told us it." He was like, "No, I didn't." Yes, you did. Yeah, really mad. So
Yeah, fusion puts it together and combines it, makes a big nucleus. And fission takes it apart and breaks it up. All right, got up? So, when we control it, we can harness the energy for a power plant. We have 3 in North Carolina that I know of. We have 1 outside of Raleigh. You stop before I think you're that crazy lady in Burlington. All right? We have 1 outside of Charlotte. We have 1 outside of Raleigh and 1 outside of Wilmington. A lot of places are doing away with nuclear power plants because of the radioactive waste, and we'll talk about that on Monday. However, uncontrolled reactions can be used in nuclear weapons. The only time that we've used uncontrolled nuclear fission and nuclear weapons was in 1945, and they were both dropped where?
Japan.
In Japan. The United States is the only country that has used them, and Japan to this day does not own or use any nuclear weapons because of the destruction that was heaped onto their country. That's really attractive. All right, now, on Monday, we need to finish this, and then we're going to take a practice test that I'm toying with Greg. We'll see what I'm going to do with it.
I think
Okay?
honestly,
There are no hundreds for taking. All right, have a good weekend. Stay in your chairs until they ring the bell for lunch.
nobody go home. I just came for this period.
Shocking, Nigel.
What?
You would only show up for my class.
Well, duh, you're like the only class I actually want to go to. And plus, if I do this another day, it's kind of, I'm gonna fail.
All righty then. You don't have to go to any of your other classes for days?
No,
Oh,
Mr. Dude, I'm failing.
oh.
He doesn't teach anything. He gives us an assignment and tells us to look up it on YouTube.
Oh, what? That's what Jessup do.
Jessup do.
What's this your own? Let's give us notes.
And I don't feel like.
Not that you. That's what Jessup do. He gives us notes sometimes. And
But this, if it's an open note, then the house is so, our notes be this long, it says be this long.
Feel me twice.
oh yeah.
I love this one.
Jessup do.
I mean,